In this lesson, we're going to be multiplying rational expressions. But before we do that, we're going to multiply some fractions together that don't have any variables. And we'll talk about how we deal with this, which is going to be the exact same concept of what we do when we start throwing variables into the mix. So we're going to do it a little bit of the long way because I'm going to have to do it the long way when I get more complicated problems. But if I were to do this kind of a shorter method, I would say, all right, what is a common factor that I have with the numerators and the denominators? So like a 16, is there anything that goes into 16 and 35 or anything that goes into 16 and 12? And then I would divide things away. But another way to do that is to actually factor the 16 completely, factor the 21 completely. So 16 consists of 4 2's, 21 consists of a 3 times a 7, and they're all multiplied together. Divided by 35 consists of 5 times 7, and 12 consists of 2 times 2 times 3. So once I have all the factors, then I'm really just looking to cancel out any common factors on the top and the bottom. So I'm going to cancel common factors. All right, and mathematically they really just become ones. So like the 3 cancels with the 3 and they technically become ones. 2 cancels with the 2. 2 cancels with the 2. 7 cancels with the 7. And now once I've canceled out all my common factors, I'm just going to multiply all the pieces that I have left. So all the numerators will go together, so it's 2 times a bunch of 1's, which isn't going to do anything. So it's really just 2 times 2, which is 4, and then 5 times a bunch of 1's, which is 5. So if I reduce that together, I'm going to get a 4/5. So let me show you what ours is going to look like. We're going to have a 2p minus 2 divided by 2. So there's our one rational. Oops, it's supposed to be a p. Times 3p squared divided by 9p minus 9. So just like here, rather than multiplying them together, rather than making them bigger to reduce them, I might as well just kind of look at them individually. So can I factor anything here? Yes, I can factor a 2 out of that. So that would be a 2 divided out, which would be a p minus 1 over p, times, I don't have addition or subtraction, so there's nothing that's going to be able to reduce out of that. And then the denominator, I do have a 9 that I can divide out, so that would be a p minus 1. All right, so since they're multiplied together, I don't even have to treat them as two separate fractions. I can really just treat it as one big fraction. So I have this on top, this on the bottom. If anything matches, I try and reduce it away. So the p minus 1 clearly matches the p minus 1 on the bottom, so they can cancel away. And if I see more, great, I can cancel it. If not, let's just lump together our top. So the numerator is going to get us a 6p squared. The denominator is just going to get us a 9p. And so now I can reduce it a little bit further. Maybe I didn't see it before, that the p's could have canceled a little bit, the 3 and the 9 could have canceled a little bit. But even if I don't see it there, that's fine. I'll put it together, and the 6 and the 9 can reduce. They can divide by a factor of 3. So that'll be a 2 and a 3. One of these p's can cancel one of those p's. So I'll have left a 2p on the top, 3 on the bottom. All right, so let's see another one. So if I have an x squared plus 11x plus 24 divided by x squared plus 12x plus 27 times x squared plus 9x divided by x squared plus 4x minus 32. All right, so we got a lot going on this one. So we have quadratic divided by quadratic times another quadratic divided by quadratic. We're trying to reduce this down as much as we can. I have no idea what a common factor is that I can divide out of individual pieces, so I'm just going to factor them and see if anything matches. So my first fraction is I need something that multiplies to 24 that adds to 11. So that will be an x plus 8 and an x plus 3. This one, I need something that multiplies to 27 that adds to 12. So x plus 9 and x plus 3 times. What can I factor here? I can factor an x out. That'll leave me with an x plus 9 divided by, multiplies to negative 32 that adds to 4, x plus 8, x minus 4. Alright, so this is all one big multiplication thing. I can make it just into one big fraction. So these pieces are all multiplied on top, these pieces are all multiplied on the bottom, very similar to what we have right here, and I'm going to try and cancel away common factors. So I see an x plus 3 and an x plus 3, I can cancel those. I have an x plus 8 and an x plus 8. I can cancel those, and technically they're becoming 1s. X plus 9 and an x plus 9 becomes a 1. So I have left an x in the numerator and an x minus 4 in the denominator. And that is what it reduces down to. Alright, and that was multiplying rational expressions.